Please subscribe and do not forget to click the bell icon so that you can always stay connected with Nakoda Education and Home Tutors.
Now let's talk about Newton's universal law of gravitation. Now according to this theory, a law, according to this law, all the objects in the universe attract every other object towards it by a definite force. And this force is directly proportional. This force is directly proportional to the product of masses of the two objects and inversely proportional to the square of distance between them. So Newton's law of gravitation क्या बताता है? It states that कि जो फोर्स एक्सर्ट हो रहा है यूनिवर्स में, जितने सारे ऑब्जेक्ट है, एक ऑब्जेक्ट दूसरे ऑब्जेक्ट को विद अ फोर्स उस पर अप्लाई कर रहा है एंड उसको उसकी तरफ अट्रैक्ट कर रहा है. नाउ दिस फोर्स जो एक्सर्ट किया जा रहा है बाय वन ऑब्जेक्ट ऑन अनदर ऑब्जेक्ट, दैट इज डायरेक्टली प्रोपोर्शनल टू द प्रोडक्ट ऑफ मासेस. जो टू ऑब्जेक्ट्स है उनकी जो मासेस है, उनका जो प्रोडक्ट है उसको डायरेक्टली प्रोपोर्शनल करता है एंड इट इज इनवर्सली प्रोपोर्शनल टू द डिस्टेंस बिटवीन दिस टू ऑब्जेक्ट्स. सो formula we can written here is F is directly proportional to m1 m2 upon it is inversely proportional to distance between these two, and that's why I have written here at the denominator. Or it can be written as F is equal to G m1 m2 upon d square, where g is constant of proportionality and it is known as universal constant. Now this law means that if the mass of one object is double, then the force between these two objects is also double, and if the distance is double, then the force decreases by factor 4. Now the value of g, that is gravitational constant, is SI unit, it is 6.673 into 10 raised to minus 11 Newton meter square per kg square. Now why did Newton assume inverse square dependence on distance in his law of gravitation? So he was helped by Kepler's third law of motion in this. So let's talk about uniform circular motion or the magnitude of centripetal force. So for this, consider an object is moving in a circular motion, with the constant speed. Now we know that for such a motion ऑब्जेक्ट पे एक कंटिन्यूअस फोर्स अप्लाई होना चाहिए which is directed towards the center of the circle, and this is called as centripetal force. So अगर ये movement होनी चाहिए, that object is moving in a circular motion with a constant speed, then the centripetal force should be acted upon on that object. So for this, if M is the mass of the object, V is its speed, and R is the radius of the circle. Then it can be shown that the force is equal to, that is, F is equal to mv square upon. Similarly, if a planet is revolving around the sun, in a circular orbit, in uniform circular motion, then the centripetal force is acting on the planet. Centripetal force acting on the planet towards the sun, is F is equal to mv square upon r. Now here m is the mass of the planet. M is the mass of the planet. Then V is equal to its speed, or the speed of the planet, and R is the distance of the planet from the sun. Now the speed of the planet can be expressed in terms of period of revolution, T as follows. Now, the distance traveled by the planet in one revolution, the distance traveled in one revolution, I'll write it here, in one revolution is equal to perimeter of the circle, that is 2 pi r. Now r is the distance of the planet from the earth, and time taken is equal to period of revolution that is t. Therefore, with speed, that is v, is equal to distance travelled upon time taken. So let's substitute the values here. Distance travelled is equal to 2 pi r upon time taken is t. Now v is equal to 2 pi r upon t, and we know the formula here, F is equal to mv square upon r. So let's substitute the value of v here, that is m in bracket 2 pi r upon t square upon r. So it is 4m pi square r upon t square. So by multiplying and dividing by r square, we get, by multiplying and dividing by r square, we get F is equal to 4m pi square upon r square, that is r square upon t cube. Sorry, it is r cube upon t square. Now, according to Kepler's third law, t square upon r cube is equal to k. So F is equal to 4m pi square upon r square k. But F is equal to 4m pi square upon k is equal to constant. And thus Newton concluded that the centripetal force which is acting on the planet and is responsible for the circular motion must be inversely proportional to the square of the distance between the sun and the planet. Now let's solve the examples which are given in the textbook, which are based on the laws which we have discussed till now. So the question is, Mahendra and Virat are sitting at a distance of 1 meter from each other. Their masses are 75 kg and 80 kg respectively. What is the gravitational force between them? So let's first write down the given things. So what is given? Masses, that is M1 is 75 kg, M2 is 80 kg, distance is 1 meter, and the gravitational constant is, we know that it is 6.67 into 10 raised to minus 11 Newton meter square per kg square. So let's solve this. So according to Newton's law of gravitation, according to Newton's law of gravitation, F is equal to G m1 m2 upon r square. We can consider here this r. Okay, so let's substitute the values here. G is 6.67 into 10 raised to minus 11 into m1 is 75, m2 is 80 upon r square, that is 1 square. The answer is 4.002 into 10 raised to minus 7 Newton. So this is the gravitational force which is between Virat and Mahendra. The second example is in the above example. This example, assuming that the bench on which Mahendra is sitting is frictionless. Starting with the zero velocity, what will be the Mahendra's velocity of motion towards Virat after 1 second, and will this velocity will change with time and how? So here given things which are force on Mahendra, that is F is equal to 4.002 into 10 raised to minus 7 Newton. Then mass M is equal to 75 kg. So according to Newton's second law, according to Newton's second law, the acceleration produced by the force on Mahendra that is M is equal to 75 kg. So it will be acceleration A is equal to F upon N. So let's substitute the values here. F is 4.002 into 10 raised to minus 7 upon 75 kg. So the answer is 5.34 into 10 raised to minus 9 meter per second. So using Newton's first equation, we can calculate Mahendra's velocity after 1 second. So Newton's first equation is V is equal to U plus AT. As Mahendra is sitting on the bench, his initial velocity is 0. His initial velocity is 0, that is U is equal to 0. So assuming the bench to be frictionless. So V is equal to 0 plus A is 5.34 into 10 raised to minus 9 into 1. So it is 5.34 into 10 raised to minus 9 meter per second. So Mahendra's velocity, will be 5.34 into 10 raised to minus 9 meter per second after 1 second. Now this velocity is very small. It will increase with the time because of the acceleration, and acceleration भी जो है वो constant नहीं रहेगा, because महेंद्र जैसे जैसे move हो रहा है towards विराट, distance जो है वो कम हो जाएगा, and that's why gravitational force जो है वो increase हो जाएगा. And as according to the Newton's second law, जैसे ही gravitational force increase हो रहा है, acceleration भी increase हो जाएगा.